High-enrollment computer science courses generate thousands of programming files. As classes scale, the sheer volume of code submissions pushes grading workflows to a breaking point. Evaluating this volume manually requires a massive expenditure of time. Human markers reading line after line of code inevitably introduce subjectivity and fatigue-driven errors, compromising the overall consistency of the assessment. Furthermore, relying on a live learning management system creates a severe latency bottleneck. Waiting for individual web pages to load, render files, and save scores over a standard browser connection stalls bulk grading operations. The Hybrid Offline Marking System, or HOMS version 3.0, is built to decouple the assessment process from the live LMS. It moves the entire technical analysis to the marker's local machine. This design creates a low-latency environment with the processing bandwidth required to execute heavy code analysis. By working locally, the system bypasses the stability issues of a remote web server. Processing submissions offline automates the routine verification of syntax. This shifts the focus for faculty, allowing them to spend their time performing intelligent academic triage on the most complex student errors. The workflow engine orchestrates the transition from code to data, routing information into 3 modular hubs: assessment, moderation, and learning. First, it ingests a config.json file, establishing strict execution timeouts and statistical boundaries for the deployment. With the parameters set, the workflow engine activates the first sequence, the assessment hub. Here, automated agents execute the student code, capturing raw granular data on functionality. That raw output immediately routes directly into the moderation hub. This second sequence applies strict statistical guardrails, filtering the data to identify anomalies, improbable scores, and signs of collusion. Finally, all of the validated results pass into the learning hub. This third sequence synthesizes the filtered scores into long-term pedagogical analytics, identifying systemic patterns across the student cohort. The outputs of this third hub generate curriculum telemetry. This is diagnostic data that maps exactly which technical concepts cause the highest rates of failure in the classroom. This modular, pipeline-driven architecture ensures that a marking event produces actionable empirical intelligence that the department can use for future planning. Generating that reliable intelligence requires a completely standardized grading baseline, stripping away marker subjectivity. This graphic illustrates the primary assessment path. The system utilizes PyBrite to conduct deep logic checking, mechanically interrogating the student's submission by comparing its internal states against a gold standard reference implementation. To handle raw Python files, the assessment agent dynamically transforms .py source files into temporary computational notebooks, ensuring processing continuity for the logic checks. However, technical variances are inevitable. Mismatched library versions or incompatible local environments can easily crash an automated script and stall the grading process entirely. This maps built-in redundancy. When the primary logic path encounters an error, it instantly routes to a functional fallback sequence. Instead of stalling, it tests specific function contracts, capturing pass or fail statuses to maintain grading momentum. The conclusion of this agent is a structured payload for every student. It contains specific feedback annotations, an objective base score, and logs of any fallback diagnostics triggered along the way. Engineering a dual-track assessment strategy ensures environmental variances never derail the pipeline, providing the clean, standardized baseline required for the next step, automated statistical analysis. A standardized grade is only useful if it is consistent. The moderation agent takes the raw scores and evaluates them within the context of the entire cohort. This bell curve charts cohort z-score outlier detection. The system calculates the class mean and highlights submissions at the extreme outer edges. By measuring exact standard deviations, it mechanically isolates improbable scores with a strict review-required status. This mathematical filtering builds a defensible quality assurance trail. If a final grade is challenged or internally audited, the department can point to cohort-level data justifying exactly why a submission was flagged. A valid grade also requires a guarantee of original work. Traditional plagiarism scanners compare raw text, which often fails against code obfuscation. Students simply rename variables or reorder independent statements to trick the scanner into reporting a low similarity score. The moderation agent solves this via pairwise annotation similarity detection. As shown here, the system bypasses the surface text entirely and analyzes the identical logical triggers generated during the execution phase. Analyzing the sequence of logic execution makes variable renaming irrelevant. If two distinct files generate highly specific, identical feedback profiles, the system flags the suspicious pattern for human review. Relying on these statistical and logic-based guardrails transforms the human educator from a bulk grader into a specialized auditor, intervening only when mathematically justified. Once the scores are finalized and moderated, the pipeline reaches the learning agent, the pedagogical intelligence layer designed to extract long-term systemic insights. This agent stores its analysis in a persistent historical knowledge base. Rather than discarding data after a marking session, it accumulates intelligence across multiple semesters. It executes annotation difficulty profiling. By calculating aggregate pass rates, the agent identifies the specific code concepts causing high-frequency failures across the current class. This scatterplot visualizes error combination pattern mining. The system tracks how distinct foundational errors interact, revealing when isolated mistakes merge into a dense central cluster that breaks integrated problem solving. This clustering triggers a partial understanding flag, indicating where students write basic syntax but fail to synthesize the logic. The timeline then expands, revealing this exact error cluster has remained identical across multiple semesters. This comparative analysis provides a vital diagnostic. It differentiates a temporary dip in performance by a single cohort from a structural, recurring flaw in the teaching materials. Extracting this longitudinal telemetry ensures that future curriculum redesigns and academic planning are driven by hard empirical evidence rather than instructional intuition. The final phase of the offline process is to apply the gathered telemetry to the curriculum standard itself. When the learning agent identifies high-frequency logical failures, it provides a clear mandate to adjust the assessment design. Faculty can update their grading criteria to move beyond simple syntax checks and focus on demanding logical cohesion. This dashboard displays that active refinement. The system extracts text from standard documents and recalculates its internal weighting to target those proven failure points. This dynamic adjustment creates a self-optimizing educational environment. As the students master basic operations, the assessment mechanism evolves alongside the increasing technical complexity of the course. With the intelligence captured and the rubrics updated, the workflow generates the final outputs required for LMS integration. The repackaging utility injects moderated scores and automated feedback into a flattened spreadsheet grid, which is then wrapped into a single zip archive. Formatted as an upload all package, it bridges this offline intelligence back into the live learning management environment, eliminating repetitive manual data entry. By integrating automated execution, statistical moderation, and learning analytics, the system turns student performance into a direct, evidence-based feedback loop for future instructional design.